Here's a brief example to practice solving for centripetal acceleration. So read through this, press pause, read through this, and then when you're ready to go through it with me, press play. Okay, so I'm trying to solve for my centripetal acceleration, and I have this formula here that lets me solve for my centripetal acceleration if I know my tangential velocity and the radius of the circle I'm making, or if I know my angular velocity and the radius of the circle that I'm making. Well, this ladybug is going to make a circle that has a radius of 0.2 meters. So now really what I need to do is to find my tangential velocity or my angular velocity. And I can find both of them actually. I only need one of them. I'm going to show you how to find both of them just for practice. So let's look over here first. Here I'm going to solve for my tangential velocity. I'm going to take the information that we're making 2 complete revolutions per minute. I write that as 2 revolutions per 1 minute. And thinking that I want my tangential velocity, I need my units to be meters per second. So first I'm going to convert between minutes and seconds by putting 1 minute on the top and 60 seconds on the bottom. That lets me cancel the minutes. Then I'd have revolutions per second. Now I need to convert between revolutions and meters. So what I want to think is, when I make 1 full revolution around the circle, how many meters do I travel? Well, I travel 2 pi r meters around the circle. That's the circumference of the circle. So here I'm converting between revolutions and meters, and I'm saying that 1 revolution is the same as 2 pi times 0.2, because that's my radius, meters. So the math I would do on my calculator is 2 times pi times 0.2 divided by 60. And I get 0.0419 meters per second. That's my tangential velocity. At this point, I'm able to calculate my centripetal acceleration. I could just take this value, plug it in here, and solve for A, along with plugging in R. But just for practice, I'm also going to show you how to solve for omega. So I'm going to, again, take that 2 revolutions per minute. And this is actually already a measurement of omega. But to make this math work out, I need my units for omega to be in radians per second. So I'm going to convert between minutes and seconds, and I'm going to convert between revolutions and radians by saying that 1 revolution is the same as 2 pi radians. So then I get my answer for omega, 0.209 radians per second. And again, I can plug that in here, and actually let's just go do that. So I'm just showing you the 2 different ways. Here I've plugged in, for v sub t, I've plugged that in here, and r is 0.2, so I can calculate this expression to get my centripetal acceleration, or I can also use my angular velocity here, square that, multiply by r to get my my centripetal acceleration, and both of these give me the same answer, 8.8 times 10 to the minus 3 meters per second squared. Our units for centripetal acceleration are meters per second squared.